Hello everyone! Today we'll learn about biocides for lower fungi. Lower fungi are those from the Mastigomycotina and Zygomycotina of the fungal kingdom which cause diseases such as downy mildew, late blight, and white rust. Biocides for lower fungi are biocides designed to control diseases caused by lower fungi. They include several types. To make it easier to learn and remember, here's a summary of these biocides. Biocides for lower fungi come in the following types and varieties. Metalaxyl, metalaxyl M, and oxadixyl from phenylamides, mendipropamide, zoxamide, and fluoropicolide from amides, amitriptyline from triazolopyrimidines, propamocop, hydrochloride, and iprovalicop from carbamatids and amino acids esters, cymoxanil from substituted ureas, flumorph and dimethomorph from methoxymethylmorpholines, cyazophamide from cyanoimidazoles, and oxathiapiprolene from piperidines. Now, let's take a look at their characteristics. 1. Metalaxyl and metalaxyl M. They exhibit strong systemic translocation properties with protective and curative effects. They are highly effective against downy mildew pathogens, with a long-lasting residual effect. These two biocides act by inhibiting the synthesis of proteins and ribosomal RNA in fungi. They carry a risk of causing high-level resistance, so they should not be used alone and are often used with biocides that work through different mechanisms like mancozeb and pyraclostrobin. 2. Oxadixyl. Oxadixyl is a highly effective systemic biocide with protective and curative effects. It offers excellent efficacy against downy mildew pathogens and has a long-lasting residual effect. However, prolonged use of this biocide alone may cause resistance, so it is often mixed with other biocides. 3. Mendipropamide. Mendipropamide is a highly effective, low-toxicity biocide that has protective, curative, and excellent preventive effects. With a primary focus on protection, it acts by inhibiting phospholipid biosynthesis, providing excellent control over most leaf and fruit diseases caused by umicides. Mendipropamide is highly active against spores during the germination stage. It can inhibit mycelial growth and spore formation. It is rain-resistant, has a long-lasting residual effect, and is environmentally friendly and safe for crops. 4. Zoxamide. Zoxamide is a highly effective protective biocide with a long-lasting residual effect and strong resistance to rainwater. It mainly acts by inhibiting the division of pathogen sclerotia and the elongation of spore germ tubes. It is mainly used for stem and leaf treatment before the disease sets in, with a recommended interval of 7 to 10 days. It is often used with mancozeb and other biocides to broaden their biocidal spectra and enhance their efficacy. 5. Fluoropicolide. Fluoropicolide exhibits good systemic properties with excellent protective and curative effects. It primarily acts by inhibiting mitosis in pathogen cells. With a unique mechanism of action, fluoropicolide provides excellent control against diseases and shows no cross-resistance to other biocides. 6. Amitriptyline. It exhibits protective and early-stage curative effects. Amitriptyline is a mitochondrial respiration inhibitor with an innovative mechanism of action. It exhibits no cross-resistance to other existing biocides, making it an ideal choice for managing resistant fungi on specialty crops. With strong residual activity and rain resistance, it is often used with dimethomorph to prevent resistance. 7. Propamocop and propamocop hydrochloride. They are low-toxicity, local systemic biocides with protective and curative effects and act by inhibiting the biosynthesis of phospholipids and fatty acids in the pathogen cell membrane, thus preventing mycelial growth, spore formation, and germination. Propamocop hydrochloride is the form of propamocop found in formulations. It delivers the same efficacy as propamocop. 8. Iprovalicab. Iprovalicab is a systemic biocide with protective and curative effects. By targeting the synthesis of fungal cell walls and proteins, it inhibits spore infection and germination, as well as mycelial growth, thus causing deformation and death of the fungi. 9. Cymoxanil. Cymoxanil offers systemic, protective, and curative effect. It is less effective when used alone and is often used with other protective biocides, such as mancozeb and organic copper biocides. 10. Flumorph and dimethomorph. They exhibit excellent protective, systemic effects and significant curative effects. They act by inhibiting cell wall formation in Biocides. Dimethomorph is more widely used. It can be used alone or mixed with others, with many combined formulations available. 11. Chazofamid. Chazofamid is a new low-toxicity biocide that provides excellent protective activity and some systemic activity. It disrupts energy supply in Biocide pathogens by interrupting mitochondrial electron transport with no cross-resistance to other biocides. It's rain-resistant and has a long-lasting residual effect. 12. Oxathia piperulin. Oxathia piperulin exhibits protective and curative effects and exerts its biocidal effect by inhibiting sterol-binding proteins. It targets a single site and carries a moderate to high risk of resistance. After studying this lesson, we now know the characteristics and mechanisms of action of various biocides for lower fungi. This is essential for selecting the right biocides and combinations for controlling lower fungal diseases. You can refer to more sources to learn more about the characteristics and applications of biocides for lower fungi. Thank you.